let's see what is streams. So stream is a sequence of data, sequence of bytes, or you can say sequence of characters. And in Java, stream it is of bytes. So the data is transferred from the one end to another end in the form of sequence, and this sequence is known as a stream. So we normally say it's a streaming is going on, video streaming is going on in YouTube. We see the video streaming, or when you watch the live crickets, so there the streaming is going on. So it is nothing but it is a sequence of bytes is passing from your server end to the client end. So it's called as a stream because it's like a stream of water that continue to the flow. Okay, so it's just a flow from your server end to client end, or your machine to machine end. So in Java, the three streams are created for us automatically, and that means it's inbuiltly available, and all these streams are attached with the console. So console means your terminal, command prompt, and three streams are like this: system.out, standard output stream is this, system.in, standard input stream, and system.error, that is standard error stream. So what is the difference between the system.out and system.in? System.out means your data is flowing from the Java program to the terminal, to the console. That is an output we are displaying on in console. So in that case, system.out stream is used. System.in, we are accepting the data from terminal into our program. So system.in is an input stream. We are taking an input using this stream. So in a scanner class, when we create an instance of scanner class, there system.in is the parameter passed to the scanner constructor. You just check the syntax of scanner sc is equal to new scanner into bracket system.in is passed, because for this scanner, using scanner class, we are accepting the input and their input stream is used. That's why we are passing system.in. And we have another system.error. Basically system.error also it's output stream, but if you want to display a specific type of error, then we can go with the system.err. And system.err, when you use like system.err dot println or print into bracket, suppose whatever error message there, so it will display on a screen, but it is in the form of red color. So you just check how to differentiate the normal output data and the error output data. So this is the straightforward character is displayed on a screen, and it is little bit colored output you will get because this is error. So I will show at the time of a demonstration the difference between out and error. Okay, now again, just point comes to the output stream and input stream. Java application uses an output stream to write a data to its destination. It may be a file or array or peripheral devices or socket in a networking. An input stream, Java application uses an input from to read a data from source. It may be a file, array, peripheral devices or socket. So the data which is coming into the program, it is input stream. The data which is going from your program, it is a output stream. It is in just a then look this diagram. This is your source. Here is suppose your program Java application, and this is your destination. So from the source, if the data is coming, it is input stream, and it is in the sequence of byte 101010. It is a read operation, correct? So you are reading a data, and the source may be file, console, socket. Okay, it may be any source. From the file you can read a data, from the console also you can read a data, and from the socket also you can read the data, and that data is coming into the program. That's why these comes under input stream. And now from your application, if you want to display the data, we have to show with the output stream. So 1010, it's again sequence of characters, it's a stream, and it is a write operation. So we are writing a data into to respective destination, and destination may be file or console or socket. Okay, so we can write a data into the file, we can display the data on console, and we can use a socket. So system.out.println, out is your output stream. System.out, it is the object of print stream, and print stream basically it's a subclass of your output stream. So we will see the hierarchy, how the Java maintain the classes related to the input stream and output stream. Okay, now first we see output stream class. Output stream class is abstract class. So it is a class available in Java in a java.io package, and it is abstract class, and that's why you cannot create a direct instance of output stream class. It is a super class for all classes representing the output stream of a bytes. So it is a byte streaming, and output streaming class is available, and all classes comes under this class under the byte streaming. And output stream accepts output byte and sends them to some sinks, that is your whatever the resource is available there. Okay, now some of the methods which is given by output stream is a public void write. Public void write, here integer you can write, integer data you can write, here byte data you can write. The flush method is available and close method is available. All these four methods handles the IO exception, and here it is throws keyword is used. So this prototype is available for the method. The description is given here. It is used to write a byte to in current output stream. It is used to write an array of bytes into the output stream, and this is a flushes the current output stream, and it is used to close the current output stream. So this is the hierarchy, inheritance hierarchy of the output stream. This is abstract class. Look, this is a square, it's a faint green color, okay, light green, and this is your faint violet. Here look at output stream is a super class, it is abstract class. These are not abstract classes, these are the complete classes. And output stream having a file output stream, byte array output stream, filter output stream, piped output stream, and object output stream. Each and every class having its own advantage, and you will find the details about all these classes in Java documentation. I will show you what we are using. So output stream, this is abstract class, so we are not going to create object of this. We are using the print stream class. We will use a buffer output stream class, and we will use a data output stream class. So these classes we will use. Print stream class already we are using because it is an object of system.out. System.out basically returns you the object of print stream class. Okay, so SOP statement. So system.out, out is a static parameter of the system class, and that's why we are calling with the class. Class name is a system, and system.out returns you the object of print stream class, and print stream class object dot println and print methods is available in a print stream class, and these are the output streams, and that's why the combination is like this, is SOP statement, and it will help you to print the output on a console. Okay, so similarly input stream class is available. Input stream class is an abstract class. It is a super class for all input stream bytes, input streams of bytes, and the methods are available. It is abstract method, public abstract integer read, then integer available, and integer close. So read method will help you to read the data, and it returns you -1 at the end of file. Available method, it returns you the estimate number of bytes that can be read from the current input stream. So if you want to check the how many number of bytes are available, then you can go with the available. It returns you the number of bytes in the form of integer. And this is instance, it is used to close the current input stream instance, and all again handling the IO exceptions. So all these classes are belongs to the IO package. And what is a package? Package is a collection of similar logically related classes. So look at java.io. IO is the input and output stream, and within a java.io package the all classes are available which is related to the our IO related operations, input and output related operations. So that is the file handling or the message passing from your program to the networking devices. Okay, Look at input stream also having the inheritance hierarchy. This is also abstract. You cannot create object of this, but we can create a reference. These are classes of subclasses of the input stream, and these are the subclasses of filter input stream. Filter input stream is the input stream. So again, buffered input stream we are going to use it. So it is like buffer we will use for file handling. Buffered input stream is nothing, is a subclass of your filtered input stream, and filtered input stream is a subclass of your input stream. So basically buffered input stream nothing but input stream. So look, the naming convention is like this. Every class having the name input stream, input stream, input stream, input stream, input stream. Here also input stream, input stream. Only the specific names are added. It's related to data, it is related to buffer, it is related to pushback, it is related to filter, sequence, object, piped, byte, and file. Okay, so we are going to use this file input stream, buffer input stream for file handling operations. Okay, and all are, so from the naming we can get the meaning of these classes. Okay, so Java itself follows the naming conventions as well as the meaningful names of the classes. So from that we can get the things, what is the basically use of those classes. Okay, so we have to remember these rules when we write our application. We have to follow the naming convention rule, as well as we have to define proper names to the variables and classes and interfaces, and it should be meaningful. Okay, so now we come to the point exactly, that is a byte oriented approach of the file handling. The last lecture we have seen the character oriented approach, file reader and file writer we have seen, and now we will see the file input stream and file output stream, that is a byte oriented approach. So file input stream and file output stream classes are used to read and write the data in a file. In another word, they are used for file handling in Java, you can say. And again, from the name you can just get the things. File input stream, it is data, it is a read operation. In file output stream, it is a data write operation into the file. Okay, so first we see file output stream class. Java file output stream is an output stream for writing a data into the file. We have a write primitive values, then use our file output stream. Instead of character oriented data, prefer for specific to character oriented, prefer file writer, don't use this. So using file output stream, whatever data we are writing into the file, it is not in a human readable format because it is in byte oriented approach. And there, if you want to do this human readable format, then we have a file writer class. It is a character oriented approach, but you can write a byte oriented as well as character oriented data. It depends on what approach you want to use it. Okay, so look, this is an example. File input stream f out is equal to new file output stream, and this is the name of the file. And this is suppose a data I want to write. You can take it from the user or you can hard code the string. Just a demo example. And here byte array is created because I want to write the data in the form of bytes, and that's why here I convert my data into the bytes. So s string object dot get bytes, it will return me the number of bytes that is into the byte array, and this b I am writing here, f out write b. So complete byte array is passed to the write method. Write method will write the data into the file, and then I close the file and whatever the SOP statements are available. And here again try catch block is used. Why? Because this is a check type of exceptions. Java will not take any guarantee whether the file is available at respective location, or file will open at a runtime, or file will execute properly, or write operation will perform by the operating system properly, etc., etc. So that's why we have to use a try catch block. It is check type of exception. If you don't use a check type of exception, if you don't use the try catch block for a check type of exception, then compiler will give you error and you cannot compile the program. So no question about the execution. Okay, so that's why try catch block you have to write it, and then Java will compile this code and then execute. Okay, so we'll see the source code, see the demonstration of the byte oriented approach. So I open my Eclipse, file output So this class is available in IO package, so we have to import the class. Import java.io. So it is available now, and this class takes an argument that is a file, right? And this is your suppose output.txt. Okay, and obviously now we have to handle the exceptions. For this, output is small p, and now look the error. So add the throws declaration or surround with try catch. So I go with the surround with a try catch, and now here we have a string str is equal to, now initially suppose this is a null, and I want to go with the scanner. Sc is equal to scanner, and look at, when we create object of scanner we have to pass an input stream, and that is system.in, and basically system.in, this returns you the object of input stream. You just move the cursor on this, just check it, look, right? System.in, this is java.language.system class, and this is in is the static parameter of system class, and the return type of this is input stream. Are you getting? Look at public static final input stream in. So in returns you the input stream, and in is a static variable, static as well as final, of the system class. So how we'll call in parameter outside the class of system, obviously with the class name, and that's why we are calling with the class name. Same for system.out. So out is not object, in is also not object. System.in, that this returns you the print stream object. Out also returns you the output stream object. Okay, that is sorry, that is your print stream object, and this is your input stream object. Okay, look, input stream object, and this is your, that is your system.out is your print stream object. So scanner is now available in util, so we have to add java.util. So now util is available, and now give a message to the user. So look, is now system.out.println, and here give the message, enter the data which you want to write. Okay, and then you just go like this, sc dot next line. Scanner will scan the data and store into the str, and then what you have to do is convert the byte error is equal to str dot get bytes. Get bytes is available for string class, and then write the data into the file. File is fout.write, and this is your error, correct? Okay, and here it is showing you error back because you have to handle again exceptions, and that is type of. So here we are going with the file not found exceptions, only file not found exception, that is output.txt. It is a file write operation related exception, so it is IO related exceptions, and that's why I go with the IO. It is common for, now again it is showing me error, that you have to import the package. Now it is gone. Okay, then we have to close this. So what is the rule to close the IO related instances? Go with the finally block, that is appropriate. For finally you just paste this. Now it is showing you error because this is inside the try block, you cannot access in this block. So what we have to do is Control X, Control V, you have to go with a null, and then so you are increasing the scope of the variable. That's it. Now it is okay, so it's F out. Now it is okay, but it is showing me error because here also you have to handle the exception. Finally block will not handle the exception, and that's why for that also at the time of closing again there may be the chances of file is not found, or file is corrupted, or file instance is already closed. Any type of exception may occur, and for this you have to go with a try catch block. Okay, so it is IO related exception in print stack will print it. Now look the code again. Look, file output stream object, name of the file, scanner, SOP statement to give a message to the user. User will enter a data, store into the string. String data is converted into the bytes and then transferred to the, then it is written to the file using FOut object, and then the output FOut object is closed. Okay, just run the code and look the output. Enter the data which you want to write. Suppose this is my data. Save the code, and now I open a file location. In a notepad. Previous code, the code is correct, output is also correct. For a txt file it is showing me data as it is, so it is the readable form. And suppose we are going to write the data as a image or video file, or you want to read the video file or image file, so there this class will help you to convert your data into the bytes. Or you want to write the data, then it will convert into the bytes and then it will write the data, and that data is not in human readable format. Here we are working on a text data, and that's why it is showing me as it is whatever data I have written. So we have to try with the image or video, then it will show me the proper input, because image files we cannot read, correct? So suppose I open an image, so I will show you. If there is an image, okay, suppose on a desktop I have an image, and if I open with a notepad, so this is not in human readable format, correct? So suppose this is notepad. Now look, you will get something like this. This is a data, image data, and this is not human readable format, but you can read this data using the file input stream object, and you can write such kind of data also into the file. That means you want to copy the image from one location to another location, or you want to write a data and you want to convert image into the sequence of character for encryption and decryption. If you want to do it, then in that case this classes will help you. So file reader and writer will not help you. So file input stream and output stream, this will help you for a byte oriented approach, because this is a byte oriented approach. We are converted into the bytes and then we are writing a data. In this example we are working on simple text data, that's why it is showing me as it is. Okay, So we will see the next demo on the image also, if time permits, and then we will differentiate the how to write the data using file reader writer and file output stream. Okay, so this is about the file output stream class. And now similarly, file input stream class is used, only it is used to read the data. Now look, it is used to reading the streams of raw bytes such as image data, and it should be used to read a byte oriented data, for example image, audio and video. Look at here how to read the data. Here while loop is used. This is suppose ebc.txt and it is in the form of byte, and then we are converting to the character. It will display on the console. So from the txt file we are reading a data, and it is in the form of byte and then ASCII values and then converting into the characters. So it is for the reading. So it is also straightforward, simple syntax, like a file reader class. Only here file input stream is used. File reader, it's a character oriented approach. Internal mechanism is used as a character oriented in Java, and file input stream, it's a internal mechanism is a byte oriented approach is used. To read a data and write a data, we have different approach. For example, from c.java file I want to read a data, so we can read a data of any file using the file input stream class, whether it is a Java file, image file or video file. For example, we are reading the data of a c.java file and writing into the another m.java file. So in that example, we have to go with the file input stream class. Okay, so this is the example is like this read operation. So we created file input stream object, and for write operation fout object created, file output stream object created. This is a source file, this is destination file. Read one by one and write into the m.java, and then we close fin.close. Also we have to close fout.close in a finally block. Okay, straightforward as example is there. Suppose we ask you at the time of internal or external, read the source file, and suppose the reverse source code is available, Java source code is available, and line by line you have to correct the source code, or source code is correct source code is available and you have to reverse the line by line. Suppose we give you the program like this, so it is also input output operations, but what you have to do, you have to apply that logic line by line. Correct? This here we are working with on an only character by character, single byte, bit by byte, bit by bit. There we have to read the line and then reverse it. So there we have to try to find out the method which is available to read the complete line, and read the complete line, store into the string and reverse that string using string reverse. Okay, so str.reverse, so you can use it, and then that reverse string you have to write into the file. Okay, so like that we will ask you the questions to do the input and output operations. So you can use a file reader or writer or file input stream or output stream. Only you have to find whatever the functions or methods are available inside this. Okay, so now the next point is buffered input stream and buffered output stream. So buffered means it's a cache memory, like, and it is used to speed up your operations. So Java buffer output stream class uses an internal buffer to store data. It adds more efficiency than to write a data directly into the streams. So buffer will help you to collect the data and then write into the streams. So buffer by default having the size is 512 bytes. You can increase that buffer size also using the buffer output stream constructor. So it makes the performance faster, and that's why buffer input and output streams are used. And how to use it? So it just an you can see the internal component of your streams, of your main streams. So first you have to create the instance of the file input stream or file output stream, and internally file input stream object or output stream object you have to pass to respective buffer input stream or output stream. For example, look here. So before this example for output stream, we are creating object fout, and using fout we are writing the operations. Now here look at first line is creation of the fout, then buffer in output stream is created, and here fout is passed to the buffer output stream. So here in using buffer output stream constructor, and using this constructor by default buffered output stream cache memory is used of a 512 bytes, and if you want to increase it, here you just give a comma and use the different number of bytes, 1024 or something else. Okay, so you can increase the buffer output stream size also. And now look at this string data is there and same operation is there, but here for write operation we are using bout object, and bout is object is for a buffer output stream. Okay, and then we are writing directly b, then flush the buffer, close the buffer, then close the file. So flush operation is important for buffer because in a buffer the rough data, raw data may be available, and you have to flush it after each and every operation. Just clear the memory if you don't want, or you don't want illegal data from the buffer, then you have to flush it and then use the other operations. Okay, so similar approach is available as per the previous example. Only buffer is used, and why buffer is used? Because it makes the performance faster. It is more efficient and makes performance faster, and buffer output stream having more methods to work on the data. So file output stream we don't have more methods on this class. Buffer output stream having the more methods, and it is more features to use on this data, and it is recommended to go with the buffer output stream. Similarly for input stream also we have to do it. For buffer input stream, to read the information from the string, it internally uses the buffer mechanism to make the performance fast. So here again buffer input stream is used, bin, and for read operation bin object is used. Now don't use fin because fin object is passed to the buffer input stream. So buffer input stream to file input stream to the buffer input stream. In buffer input stream you can read the data. Same again b, just close the operation for buffer also and file also. Okay, so I hope you clear about this. You just work on the buffer. It is a more efficient and faster. It is recommended to use it. Okay, next thing is if you want to use the different modes. So basically when we are writing a data into the file here, so file output stream or file writer. So I will show you the code with the file writer also. File writer, and here when you run this program, then the write operation will perform, but this data is overridden onto the previous data of abc.txt if it is already available. And if you don't want to do this, what we have to do is, so we have to use append mode, and append mode is like this: file writer fw is equal to new file writer, and here abc.txt, after here just give a comma and pass a second parameter to the constructor, and that second parameter is a boolean type of parameter, and boolean value is either true or false, and you have to pass it true compulsory. And when you pass it true, then abc.txt will if it is already available or it is created, after that the data is not overridden, it is appended on a previous data. Okay, so true parameter you have to pass compulsory for abc.txt. So it is append mode. Okay, so I stop here. If you have a doubt, you just make a comment. Just